Okay, so we'll start now.
Okay.
Can you see my screen?
1 second. Not yet, sir. I cannot see it.
No, I didn't share it.
Yeah.
Now can you see?
Yes, sir.
Okay. Yesterday we were doing arrays, right? So
Yeah.
we're supposed to solve one question. So we'll solve that question today. We are going to reverse an array. So we'll be solving that, okay?
Okay.
What was that? Yes, arrays, reverse an array, right? This was the question.
Yeah. Reverse
So
scenario. I
yeah,
didn't do it, sir.
you did it?
I didn't.
Okay. Okay, no worries. So in this question, we need to reverse an array. So in this case, you see you have an array with elements 1, 2, 3, 4, and 5. So when you reverse it, you have to reverse all the elements by its position. Okay. So if it is 1, 2, 3, 4, 5, you have to get the output 5, 4, 3, 2, 1. Okay.
Okay.
So what will be the output in this case if you have an array 1 to 1? Then if you reverse it, what will it will be 1 to 1, right? Again.
Mm-hmm.
Yeah. So let's solve this question. We have multiple ways to solve it. So our first way to solve it is using swap. So we can, this is a brute force way, or you can say you will swap the first element with the last element. So something like that. So first element will get swapped with the last element. Something like that will happen. And in the second case, if you have an integer, and if this integer is a wrapper class, in case if you have a wrapper class, something like that, in that case you can use collection dot reverse. So this is our second method. Okay,
Okay.
first method, second method. Um, how can we solve it? And third way is by copying the elements of an array into another array. So third way is copying array elements into um, into the array. So we'll be going through each method one by one. So let's go with the swap method. So in this case, you can find out the. I don't know why I'm getting my own voice. Do you have your speakers on?
No. The mic is off.
No, a speaker
Yeah, speaker is it's off, sir.
for both device.
No, no, no.
At least one device should be off.
Yeah, one device is off, one is on, which I'm listening. I'll just put my AirPods, sir.
Okay. Yeah. So in this case, we'll be swapping it. So how we can swap it? We'll just use a while loop, and we go from start and end. Now, what will be the start? So start will be your um, array of 0, right? Anti start is equals to 0. And what will be end? So end will be your n, okay? Because it is the end, like it is the size of the array, okay? So we can make it end. Now, how we can solve it? So we just need to swap the elements, okay? Swap the start element with the end element, okay? And we will be moving the pointer from start to end one by one, okay? Now let's do this. So we'll just create a temporary variable. We'll just say temp, and we will store the start element over there. And what we can say, we'll say array of start, and now we have to swap. Okay, so array of start is equals to array of end. Array of end is equals to temp. So by this, we swap the elements. Now we have to move the pointer. So we just say start plus plus, and we say n minus minus. And if you print it now, so we can print the element of array. But I don't think we need to print that. So I think we are good to go. Let's run it. Let's see if we get our output. So um we get our index array index out of bound. Why should could it be n minus one? It says index 5 out of bounds for length 5.
Out of bounds.
So I don't know why is this
Minus
happening.
one. Oh, you put the minus one.
No, we don't really. Maybe, maybe. Index 5 out of bounds for. Okay, yeah, here we need to take minus 1. Now I think we are good to go. So start is 0, end is n minus 1. And we have our while loop, and we start from start and we go till n. And we swap each elements and we move the pointer to. So we let me just explain this what is happening here. So um, we have an array. Let's say if the array is 1 to 1, okay, 1 2 1. So this is your array, and let's say this is index 0, this is 1, this is 2. Okay. Um, just a second. Yeah. So this is your array, right? Now at the starting point, we are here, right? We are at index 0,
Zero.
and our end is 2, right? So this is our end. Okay.
Mm-hmm.
So this is your start, and this is your end. In the first case, we are at start is equals to 0 and end is equals to n minus 1, which is this. Okay. Now we start from this. We said that we have a variable which is temporary variable, and it is storing the value of array of start. Okay. So
Okay.
what is happening is, um, just a second. We have a temporary variable, and in this variable we have currently 1 stored, because this is your array of start. Okay.
Mm-hmm.
And now what we are saying, array of um, start, which is your array of 0, is equals to array of end. Okay. And now what is array of end? It is 1. Let's
One,
say it is 3, and it should be better. So
three.
let's say if it is 3, so we get our 3. So now what is happening? We are changing the value of this. Okay. We are
Mm-hmm.
saying we are cutting this down and we are making it 3. Okay. Now this is 3. Okay.
Okay.
Now in the second step, what we are saying, in the second step, we have array of end is equals to array of end is equals to temp. Now what is temp? So temp is currently storing array of start, right?
Mm-hmm.
So temp is array of, wait, let me just write it here as
The first
well. Array of
array.
start, which is equals to 1. Okay.
One.
Now array temp is array of start, and so what will be array of end? It will be equals to 1.
Temp.
Okay. So we got this one, right?
Mm-hmm.
So our current array of start is 3 and array of end is 1. So we swapped the elements, right? What we did?
We swap the elements.
We swap the 1 with 3 and we swap the 3 with 1. Okay. Now we will move the pointer. We say that now this pointer is invalid. Let's go to this pointer. So start is moved by 1 and end we decrease the value of end. So we go here. Now start and end both are pointing at the same point. Okay. If both are pointing at the same point, so 2 will not be swapped, right?
No.
Even if it's swapped, so it will still be 2, right? Because what's the point? Okay. So now what is your array? So your array will be 3, 2 and 1. So you see that you reversed your array successfully, right? So this
Yeah,
is the
actually.
logic what we are going to use to reverse the array. This is using swapping. Okay.
Mm.
So our first method is done, I guess. Let me just comment it out. Now what is your second one? We can use collection dot reverse. How we can use that? If we have, suppose if we have this integer, then in that case we can say we can use collection dot reverse. Now there is difference between int and integer, okay, and integer. So there is difference because this one is your wrapper class, okay, and this is your
Okay.
primitive.
Primitive. Okay.
And this one is primitive, and the integer one is your wrapper class. So wrapper class will have additional functionalities. Okay.
Yeah.
Now this is your wrapper class. We just change it to wrapper class. Now we can reverse it. So to reverse it, we'll just directly say reverse the array. And I think this is good to go. But I don't think it will pass because yeah, cannot find symbol reverse. Hmm? Maybe I'm missing something. Let me check. Oh, we are getting error in main.java. Okay, what happened? We are getting error in main.java because in main.java we have int, right?
Oh
So
yeah.
let me show you that in collection reverse array in Java. Okay. So how you can reverse? So you can directly reverse it collections or we have to use collections. I think we missed S. How we can run it? Okay, never mind. Maybe we can import it. Import java.util.collection. Let me check. I'm not sure if it will run this. Or maybe let's import everything. Okay, so this is because integer cannot be converted to list. Huh? Int cannot be converted into integer. Okay, so this is because of the main function in the backend. We have a main function where we are using int, so we cannot do that. So we cannot change the parameter. Okay, it will give you errors. So now at least you know that we have another way to reverse it using collections.reverse. So this is your second way. What is your third way? In your third way, we can you can just copy and traverse through your array and you can reverse it directly. Now, how you can do that? So you just create another array. Let's say it is your array two. Okay. Now, array two you can just directly create using this. You just say that you have n integers here. Now you'll just go through your previous array. You just say int I, and we are just going through the array. We are using for each loop this time. Okay, here what we are going to do, we are going to traverse through the array and we are going to store the values in array 2. Okay, so we are just okay. Let me just create another counter variable maybe. int a is equals to 0, and we are saying that int uh, one second, array of 2. No, we can't use for each loop, it will be hectic. For int I is equals to, we'll go through the reverse direction, okay? So you already know that we can start from int I is equals to 0, I less than n I plus plus, right? This is usually
Yeah.
what we did, right? But
Yeah. Yeah. Yeah.
there is one more way to reverse, to traverse it from the back, okay? From the end to the start, we can traverse through the array reverse, in reverse direction. So in this case, what we can say, we are starting from I is equals to n minus 1, and we are going till I greater than equals to 0, I minus minus, okay? By using this, we can traverse the array in reverse direction, okay? We're starting from the end index. So this is your end index. This is your starting index. And we are decrementing the value of I. Because suppose if you have I is equals to 3, so we cannot increase the I, right? We have to decrease the I,
Degree. Okay.
yeah, to reach the point, this one, to reach the start
Zero.
index, right?
Starting. Yeah.
So we need to decrement it. Now in this case, what we can say, array of 2, we should have one pointer. Let's say a is equals to 0. So I'll just say a is equals to array of I. Okay, and we'll just have to increment the a pointer. So what we are doing, we this is your pointer. Okay, this points to the element 0, index 0, because we have another array, right? Now we want to traverse through this array as well. So we are saying array 2 of 0 means start of array 2 is equals to end of array I. Okay.
Okay.
Now what we can say, we'll just say array is equals to array 2. Will this work? I'm not sure, but let's run it. So we got the wrong answer. We were not able to do this. Okay, in this case, since we are not since we are not printing anything, it is getting printed directly, and we are passing it by reference. So I mean, I'm not sure how we can change this. Let me just print the array 2 for now. Okay.
Okay.
So I'll just
Let's
print
see
the
how it
array
will.
2. Yeah. Print, let's say array 2 pay plus. Okay.
Sir, why plus space?
We want to print one space as well, right?
Okay.
So again, it will be a wrong answer, but that's fine. So you see that our array 2 is correct, right? 5, 4, 3,
Yeah.
2, 1. And this is your array 1. So how
I
can we
think we should
clone it? Is there a way to clone it?
we should
Um,
not print array 2, sir.
why?
No, no, we should not print array 1.
Oh, I think I've got an idea. We don't have to create this array, right? We can directly say array of 0 is equals to array of 5, and this should work. Let's run it. Okay, in this case, we are again doing the same thing. So we are trying to swapping the elements, but it's not working.
Yeah, it's 5, 4, 3, 4,
No
5.
worries, we have another idea. So what we can do, we'll just traverse again. I don't want to do this, but we have no options. So we'll just traverse through the array 2 again. We'll say I is equals to 0, I less than n, I plus plus. We'll just say array of I is equals to array 2 of I. That's it. This is the last option. Now it will be accepted. What happened?
Wish.
Oh, we removed the array 2, right?
Yeah. Should put it back.
Array 2 is equals to new int. We are printing this. Okay. So what we did first, so we created another array and we copied the elements in reverse direction in that array. And now what we are saying, we are going to traverse again through the array and we are storing the values of array 2 in array I. That's it.
Put it.
What is happening? We are just traversing. So we are saying that if we have this, so we are going from 3 to 1 and we are storing it in an array 2 and we are saying what? Now this array 2 will have 3, 2, 1. Okay. And this will have index 0, 1
One,
and 2.
two.
Okay. Now we are saying that we just want to make, for example, array of 0 is equals to, we are saying that array of 0 is equals to array 2 of I, or you can say array 2 of 0. So in the previous case, what we have in array 0, we have 1. We are saying please change it to array 2 of 0. So what is array 2 of 0? It is 3, right? So it will get reversed like that. Okay. So that's how we can reverse array in 3 ways. So now you know all of them, right? This one is the best one. The by swiping it, it's the most optimized. And obviously collections dot reverse is always the best option if you have wrapper class with you. Yeah. Um, Now what we can do? So our array is done, right? Submit the
Yeah,
answer.
erased.
Let's learn the collection. Okay, we'll just go through collections. I will just go through a brief overview of collection. Will not go very deeply, right?
Okay.
So it's in your, I think it's in your unit 4 or something.
Yeah, yeah. I think it's in me.
Yeah. Okay.
Let me just check.
Okay.
Sir, I think collection is in unit 3 because
It's in unit 3.
yeah, because unit 4 they've never.
Okay. No worries. Okay. Now what is collections?
Mhm.
Just read out these things. Collection in Java is a group of individual objects that are treated as a single unit. Um, in Java, the collection interface. So we have two types of interfaces, right? One is map, one is collection, right? I
Yeah,
think I've already gone through this one, right?
yeah. I think we have done this.
Yeah, so we have this, right? So this is your list. Um, and we have another one which is your map. So in map you have your hash map, right?
Yeah.
So why do we need it? Because we wanted to have a separate implementation, um, something like that. So in your collection framework, you have these things, right? So you have the interfaces. So you have iterable interface, list, collection, queue, set, sort set, PQ, and these are your classes which are implementing the interfaces. So if you have an interface list, so this class are implementing that.
Mhm.
Yeah. So we have interfaces that extend the Java collection interface. So one of them is iterable interface, this one. So iterable interface is the root of the collection framework. So if someone asks you what is the root of collection framework, you can answer that iterable interface is the answer. Its primary purpose is to provide an iterator to traverse. Yeah, so this interface basically it is to provide iterator to traverse element. Now, what is iterator? Then let's give you an example of array. Okay, how we were traversing the array. So we are using I, right? So int I is equals to 0, I less than n, I plus plus, right?
Mm-hmm.
So I is your iterator in that case. Similarly, if you want to iterate over any collection like list or something, or maybe hash map, something like that, in that case you might be having some iterator. Okay. So this iterable interface will provide an iterator to traverse the elements defined by its single abstract method iterator. So this will have one abstract method which is your iterator.
Mm-hmm.
So you can use that. Now what is collection interface? So this interface extends iterable and serves as the foundation of the collection framework. So your collection interface will have some common methods. Like suppose if you created one linked list and you wanted to add some element, or maybe you created an array list. So collection interface will provide the common methods which are being used in all the interfaces. For example, in your array list, all these classes, all these classes use same function name, which is your add. So if you want to add anything in your list or maybe in your stack, in your queue, you can use the common method which is add, okay, to add the elements,
Okay.
right? And you have a remove method to remove it, clear method to clear it. So yeah, all these things. Let's see the list interface. So this is your list interface. This is a generic one. So what do we give here? We give the data type, okay. So this is your list interface. So you see the live example of polymorphism here, right? So many forms, right? This list can have many forms, right?
Yeah.
So this list can be an array list, it can be a linked list, it can be a vector, so it can be anything, right?
Yeah.
Now
But
what
the
is
same
this?
list.
Yeah, what is this angular bracket? So these are representing the data type, and it is written T here because it's a generic one. We don't know what will be the data type, right?
Mm-hmm.
Okay. Whew. Let me open IntelliJ. Do I have anything installed or what? Okay, okay, okay.
Sir, yesterday I was writing a code in IntelliJ IDEA. I don't know how to add package.
Now to add package, just right click here, new,
Yeah.
um,
Oh, okay, new.
wait, not here, maybe
I
here.
was doing generate, but in generate it was not coming, sir.
No, generate, we don't do that. So suppose if you're in Java, right? So you just go
Okay,
new and you can create package here.
package, okay.
Let me just remove all this. I don't know why my PC is very slow right now. Let me just get rid of some. Collection. Okay, save some RAM. Yeah, so what we can do here, let me give you some examples of collection. So what are collection? You can collection you can import it using import java.util.collection.
Okay.
Okay. Now what we can do, let me just create one collection that is array list. Okay. So we'll just give a list, and you see that you get uh, angular brackets here, right? So this
Yeah.
represents the data type, and this is the generic one. So we can just write, and we'll just type we want the data type to be integer. Now you see we got some error, and we hover here, and we see cannot resolve symbol list.
One,
So we
sir, please can you give me a minute? I'm just getting an important call, please, sir.
okay, no worries.
Yeah, just a minute. Hello, VP. Yes, back.
You're back.
Yeah, yeah.
Okay.
Sir, are you
So
getting any like background voice of the rain?
yeah, a little bit.
Uh, I don't put noise cancellation, but
Yeah, no
oh yeah,
worries. That's fine.
now it
That's fine.
okay.
So we have list. So list comes under your collection. So list is an interface which comes under your collection, and but we are seeing some errors, so we need to import the list, right? You can hover over here and you can press Control something. So it is under util.list. So you see we have all these things under util.list. Okay, now we can create that. You say li is equals to new. We'll say array
Sir,
list.
what things we have under util.list? Come again?
Um, we have all the collection things like list, array list, all those things under util package. Okay.
Uh,
So this is a way to create the list. So list integer li is equals to new array list, and you can write the data type here as well if you want, but that's unnecessary. You don't have to. So you need to give the angular brackets. Okay. You see the angular brackets, right?
yeah,
So
like
to declare the
less
list,
than.
yeah, yeah. So declare the list, you need to give the angular brackets here. So that's how you create the list. And if you want to add anything in the list, you can just say li.add. Let's say you want to add one. Since it's an integer, you can add one. If it's a string, it will give you an error. Okay. In that case, you need to add something which is string. Okay.
Okay.
For example, this. Okay. So never mind. So this is your list, and how you can traverse over your list. Let me just add few more things here. So just copy and paste. Okay. Now we need to traverse over the list. So we'll say we can use for each loop every time in your list, and we can print it. Oh, sorry, it can be integer, right? Have to be string because our data type of list is string, right? So now we can print it. We'll just say out, and we can print it. Okay, so that's how. Let me run this. This yeah, you see the answer, right? So you added those elements in your list, and we are able to print that as well
So you use that other na for for what? For
for each loop. We can use normal one as well. We can say int I is equals to 0, and we go through li dot size. We don't use length here because it's a class, right? Because array list is a class. So size I plus plus, and we can print directly. We say that li dot get. So these have getters and setters. Okay. So this is your get method to get the elements out of it. So you remember that in case of array, in case of normal integer array, right? In this case, what we were doing, so we were directly fetching the elements, right? Array of 0, correct?
yes, sir.
But in case of list or something, or maybe any collection, we have to use dot get method. So it's a getter method, okay? And we have to use this, and we can just pass the value what we have to get. So this is similar to this. So li of 0, we can't use this because it's your part of collection, right?
Mm-hmm.
It's a, maybe you can say it's a class. So you can't use it. You can directly access the values, right? So in this case, you have to use the getter. So li.get, and we need to pass the value. So that's how we get the values of the elements. Okay. All right. There is nothing
Yeah,
much
okay.
into it. What do I explain to you? So array
Sir,
list
can you send
provides
me that code which you just wrote, please?
this one.
No, yeah, I'll just keep it for my reference.
Okay. I mean, I'm recording the lecture, but
Oh, it's recording.
yeah, it's recorded.
Oh, okay, then it's fine.
So this is your array list, and it provides a dynamic array in Java that resizes automatically. So what was the issue with your normal integer array? So the issue was you cannot change the size of the array, right? Because that
Mm-hmm.
was fixed one. So if you create a normal array, so that will you have to always provide the size that you want to create a fixed size. Either you create an array or you create a vector. If you create a vector, then it will get automatically increased. But we don't want to create a vector, so we'll just go with the array list, and it will provide you with a dynamic array. So you can keep on adding elements into it, and it will resize it automatically as elements are added or removed. So it will resize it. Okay.
Okay.
But it is slower than the standard arrays, and it is efficient for frequent modifications. So never mind. So it supports random access but cannot store primitive types directly. So yeah, so array list, you see that here in the array list, you see we are not using int, right? We
Yeah,
are using a wrapper class. So
wrapper class.
yeah, so it only supports the wrapper class, like integer or character. So you have to not give primitive types. So let's see, let's try to give the primitive one, okay? And see what is the issue. In this case, if we are giving it a primitive value, so you see we get some error, right? And we hover over here, we see that type argument cannot be of primitive type, okay? So you have to give something which is wrapper. So we can give this, okay? But we need to add the values, right? Like 1 or 2, something like that. So do you understand, right?
Yeah,
What is the issue with the primitive one? With using
yeah.
the collections? Okay. Hmm. So this was your array list, and you have some methods, for example, add, remove. So you can remove, you can print out something. And similarly, you have a linked list. So you can do the same things here as well. But in your linked list, you have a reference of those elements as well. So it is a linear data structure where elements are stored non-contiguously. Okay. So what was the case of
Yeah,
array list? So in array list, we were storing it in contiguous manner, right? But in the linked list, what we have, we can store it in non-contiguous manner because we know each and every location of those elements. Each node contains data and a reference to the next one. Okay.
okay.
So in linked list, we have a node, and that node will have some data and a reference to the next node. Now, what is a node? So node is basically, you can say that node is a class. So you create a class of node, and you can store the data and reference to the next node over there. So it will form something like a chain linked by pointers. So I mean, I will go through this again when we study linked list. Now, what is actor? So it provides a dynamic array in Java similar to array list, but with synchronized method for thread safety. And it is slower because of synchronization issues. It's useful in multi-threaded environment like ArrayList. It resizes automatically during element manipulation. So when you need to use some thread safe implementation, then you can use vector. We'll go through what is thread and all when we do multi-threading. Okay. Now the next topic is stack. Now what is stack? So stack is your last in, first out. So you can say
Last
that,
in.
yeah. So you can say that you have a table and you are keeping your books on top of your books. Okay. So you are creating a stack of books. Okay. Now if you pick out some book, you will always pick out the last one, right?
Yeah.
So at the top you can only see that which is at the last.
Last. Yeah. The one you put last.
Yeah, the one we put at last point. So it supports core operation like push, pop, eek, empty, search. So we have different methods in stack as well. So that is your push, pop, peek, empty, and your search. And stack is your subclass of vector, and it inherits its properties. So here you see we are creating stack. So stack, we are giving some data type to it, and we're using the new keyword to create an object of it. And this is redundant. You don't have to write it here as well. And how to add the element. So in case of stack, it is different. We have to use, instead of add, we use push. So we push into
Push.
the stack. Okay.
Okay. Okay. Push and pop. Yeah, I
Yeah,
remember.
push and pop. Yeah, correct. And in the case of a stack, if you want to iterate over the stack, we have to use a iterator. Either you go through the for each loop, so that will be easy, or you just create an iterator.
Okay.
Okay, so in this case, we are seeing this is from the iterable um, interface. So this iterator is from the iterable interface and iterator, and we are giving the data type. We are saying itr, we are saying stack.iterator. So we are using that iterator. Okay. Now what we are seeing, so this iterator will have some methods like has next. So while iterator dot has next means while we have elements in our stack, in that case we'll print the next element. Iterator dot next. Okay.
So this is a different kind of iterator if we don't use that I plus plus I is less than or equal.
Let me copy it. Let me show you here. So you see we have a stack we need to use, or maybe just add these elements, and we have to add iterator. Okay. So looks good. Um, Now you see that we are creating iterator, but do we have another method to use that? So we can comment out and we can say, can we use some other thing? For example, for each. We say string I in your stack, right?
Mm-hmm.
And we can directly print out those elements. So this out, out. So this will also work, okay? So if you print it, um, you see we added geeks for geeks. We got the output, right?
Yeah.
Here, geeks for
Uh-huh.
geeks.
Yeah, yeah, yeah. Push. Yeah.
So you know, like this much line of code, you don't have to write if you're using for each.
Okay.
If you're not using for each, then you have to write. Then you
But
have
I think for each loop is better than the normal for loop,
no,
right?
no, no. It's not better. It's only better if you don't want to apply any operations. You just want to fetch the values. In that case, you can
Oh,
use, yeah. If you want to print something, then you can use that. But don't use it every time.
okay, sir.
It will give you errors. And I'm not
Okay.
sure if your college teacher know about the for each. They must be knowing, but yeah, you know how are all the teachers, right? They're
Yeah, they
old
want
school,
you to
so
follow the.
yeah, they might not know the new methods or something like that.
Mm-hmm.
Now, what is your iterator? So in iterator, you create an iterator for to traversing the stack. So we create a iterator itr, and we are saying dot iterator, And here what we are doing, while itr dot has next, so it will also print the same thing. So if you print it, you run it, so you get the same thing, right? The
But
XOR
it
gate.
will not, sir. It will not line after line.
You see
Or
the ln, right? Ln
yes,
here.
yes, yes.
If you write the ln here, it will print line by line.
Okay, okay, yeah. Got it, sir.
Yeah, so that was it. That was it for stack and your vector, array list, linked list. Now we have our queue interface. So this is your queue. You can create it as priority queue or array queue. There are two types, okay? And this is your first in first out principle. It's based on if you put it first, you'll get it first, okay?
Mm-hmm.
It's not like your stack where you put it first, but you'll get it at last, okay?
Last. Yeah.
So it is like you have a, you can say a room where you have two gates, okay? One guy is entering from the gate and you can just get out from the other gate. So that is your queue.
Mm,
Queue means it is a line. Suppose you are at the counter, you want to bill something, you have bought something, you want to get a bill. So you
mm-hmm.
stand in a line. So you stand in a queue. So that is a queue.
Yeah.
So if you are standing first, you will always get your bill done first.
Yeah.
Okay.
Yeah.
But in case of stack is like putting on top of it. So you will only get
Oh,
once the last one is out. So that is your stack.
good.
Oh, now where elements are processed in the order they are added, similar to a real world queue, ticket booking, etc. Mm, we have priority queue, hierarchy queue, event database. We can go through this maybe later.
Cute.
We'll just take a 5 minute break. Okay.
Okay, sir.
Are you there?
Yeah, sir.
Okay. So we were at the priority queue and DQ. So I think you will have to read these when you do the data structures and all, right?
Yes.
Okay. So let me just go through the priority queue once, so you get the idea. So priority queue you can create it using this priority queue in t-shirt PQ new priority queue, or you can directly say queue in t-shirt PQ is equals to new priority queue. And what it does is it will do on the basis of the priority. Okay, so you can see the definition. So it will process the elements based on their priority rather than insertion order. So it doesn't matter if it
So what
is.
will set the priority, sir?
um, we'll get to know that later. This is just a definition, okay? When I go through the data structures, I'll let you know. So it uses a priority heap for
Okay.
internal storage, and elements are ordered either by their natural ordering or by a custom comparator provided at construction. Now we'll go through the comparator after this. So there are two things like comparator, comparable interfaces. We have functional interface, and there are so many things to learn. Okay.
Mhm.
Now we have our DQ interface, so it will extend the queue, and DQ is equals to new array DQ. So it allows insertion and removal of elements from both ends. Okay. Um, yeah, you'll get to know about these when you do the hands-on. So it doesn't matter if you go through this for now. Now what is set? So it will store only unique elements. It will not store any duplicate elements. Suppose you got some question where you need to store something which are unique, okay? You want to find only the unique ones in your list, okay? In that case, you can use set instead of array list or linked list. So you can directly use set, and set hs is equals to new hash set. So here, we're using the hash set, and you can get the unique values in your array, or sorry, in your set. So if you're adding geeks for geeks is very helpful. So it will only store geeks for is and very helpful. Okay, but the order will not be same. So it will print in any order you don't know. Okay,
Mhm.
so the only issue with the hash set is you don't know the order. Like what will be the order? In that case, we do the linked hash set. Now what it will do? So it will store the unique elements, but in the same order in which they are added. Okay,
Okay.
so that's how if you want to store some unique elements and in the same order, you can use the linked hash set. And if you don't care about the order, then you can just use the hash set. Okay, and just you just only care about the unique elements. That's it. And you know that you can always iterate over hash set using iterator. So you create an iterator, you give it hash next, or if you don't want that, you can just use a for each loop and you can always iterate over it. Okay. Similarly, for the linked hash set as well, these things are same. Okay. Now, what is sorted set, uh, or you can say tree set? So it will sort everything on the basis of you see what we can say that there was some word. What was that word which were in that question when we were sorting out things? Lexicographically. Yes. So it
Yeah,
will
let's
sort
see.
the elements in lexicographic manner. Now after that we have map interface. So to iterate our map interface, you can use entry set. We'll just go through it once. Yeah, so yeah, we can use entry set to iterate over our map. So this one is important, and we'll see why. So what is hash map? So instead of going through this stack and all, For now, I'll just go through the hash map. What is hash map? So it will store the key and value pair. Okay. What it will store? The key and value. For example, this one is your line number, right? So this can be your key, and at line one you have packaged org.example. This is your value. Okay. So these
Okay.
are your
Yeah.
key and these are your values. So at line number three we have this line. Okay. So hash map is nothing but a key and value pair. And how you can create hash map? So you can always use map interface. You say I want to create integer, and in the other one we want to store string is equals to new, huh? Map is equals to new hash map, and yeah. So this is how you can create. So I'm declaring an hash map. Okay. This is how you create an hash map, and you see the our key is integer, right? So key here in this case is integer, and value here in this case is your value is your string. Okay. Are you able to understand this? Are you there? Zishan, are you there? Are you talking on mute?
Sir, the network was a problem. Can you hear me now, sir?
Yeah, I can hear you. So you
Yeah,
see,
it's just that I put my
yeah,
phone in the field or
no,
something.
no worries, no worries. So you see, we have key and value pair, right? So this integer is your key,
Yeah.
and this string is your value. Okay. Now, how to push an element into the hash map? How we can push it, right? So we can use map.put. We say that at key one we want to store Zishan. Okay. We are
Okay.
saying at key two we are going to store Mukund. Okay.
Yeah.
So can we print the elements using the, let me say, using for each loop? Let me check if we can do that. I'm not sure if we can do that. Let's see. Um, let's print out the elements. So like this will not work. You see the error. It says for each is not applicable to hash map. Okay. So you cannot always use for each loop in every case. Okay. So in this case, you see we can't use for each. We can't use for each in hash map. Okay. So what we can use to iterate? Can we use iterator?
Yeah, we can use
Um,
iterator.
so iterator I is equals to, how did we create that? Mp dot iterator, something like that. So you see, but the
Correct.
problem in this case is we are still getting the error. Now what is the error? We cannot use iterator in map. So that is the issue with map. Now how we can iterate over a map? So to iterate over a map, we have to use something called as um, entry set. Okay. So we have to use something called as entry set. Okay. Now how we can do that?
Okay.
So you have to learn this properly because this is very useful. Hash map, you will hash map, you will use it all the time when you do the data structures.
Hatch map.
Yeah, hash map you will use every time. It is very useful, and
Okay.
Now, how to iterate over a hash map? In that case, you'll just use a for loop. You say map, and you'll say something like this, and you'll say entry. You'll say map dot entry set. Now it is giving you error, and let's see. It requires some data type. So we just need to give what was our data type, integer and string. So now we are good to go. Okay. And what is the issue, man? What's the issue? No? Entry dot map maybe? Oh man, even I am forgetting this. Map dot entry, yeah man.
Map dot.
So we say map dot entry, and now I think it is good. Let me just go through it. I forget about these things. It's been a while since I used this. So I don't see any issue with this. So I think we are good to go. Yeah, we need to give some value. So we are saying that m. Let's say we are using m here, and in this case, how we can get the values? So we can say get key. No, or we need to use m dot. So you see we get key, right?
Yeah. So,
So
where did you declare M, by the way?
here,
Okay, okay.
or
So
maybe
this
let me
one.
write it entry so it is more visible. So let's print out some values, okay? Let's say out, and we say entry dot get key, okay, and plus, and we'll just add some spaces and colon, and we'll just add m entry dot get value, okay. Now we can print out this. Let me just print it. You see, at our first key, we get our values Zishan. So we got the entry dot get key, and get key is 1 because we put the 1 as our key and Zishan as value, right? And get value is your value, right? So we get the Zishan as your value. Okay. And
Uh-huh.
when this loop get iterated again, so you get our get
Uh-huh.
key as 2. Okay. So it is
Two.
2. Yeah. And you see the value is Mukund. Okay. So that's it. That's how you can iterate over a map. And there are a lot of more things, like there are other methods like get or defaults, and okay, yeah, there are other methods. Let me see if it is here, so we can just go through it directly. Okay, never mind. So now you know at least that how to iterate over a map, how to create a hash map, right? And you will definitely forget
Yep.
about this syntax. So please try to do some hands-on, try to solve some questions on hash map maybe, because this is very easily you can easily forget it. You can see that I forget about this.
Yeah, sure.
So map.entry, and we have this, and we used mp.entry set, and now we got our get key and get value, these things. Okay.
Okay.
Yeah. So these are related to your hash map. Okay.
Yeah.
And just a sec. Where were we? Yeah. So Java basics is done, I guess. Almost everything. Please let me know if you have any doubts.
Yeah, sure, sir.
Interfaces, I think you already know, right?
This note, please, this one, I'll get it in Geeks for Geeks, right?
Yeah, you can
Yeah,
get all the
interfaces.
notes from Geeks or Geeks. You can directly search it. It is very famous website.
Okay, okay.
Okay.
Yeah, I've heard of it before. My one friend told me.
Yeah. Okay. Now we'll go through some interfaces.
So the
We have.
company working for you guys use Java.
Yeah, we use Java.
Okay, that's
Not
good to know.
exactly. Exactly, it's Open API specification which we use to create our Java code. So we don't even have to write the advanced Java. We just write the spec APIs, like we just write the specification file in JSON format, and it directly creates all those Java files which we create manually. So that's amazing. And in Java, in respect of Java, if you like to ask, I think we'll most probably use Spring Boot and all.
AI.
Yeah. Let's go through this comparator interface. Now, what it is. So basically, we want to sort our objects. Okay. So to sort the objects, we use the comparator interface. So this interface in Java is used to sort the object of user-defined classes. So we know how to sort the integers, right? So we can just directly compare it and just keep on the keep doing the for loop and compare it and swap it, right? So we can do that. But if you want to sort the objects, in that case we can use the comparator interface. It comes under the java.util package, and
Okay.
you see we have a compare method and some object and object 1 and object 2. So we want to compare these two objects together. So this compare method will return either a 0, a negative value, or a positive value. So if it's a negative value, so that means the object 1 is less than object 2. If it's a positive value, that means the object 1 is greater than object 2. If it's a 0, then these two objects are equal. Okay. When do you want to use a comparator? So you can use it when the sorting logic should not be inside the class. So in that case, you can use it. And yeah, you want to sort by multiple fields, like yeah. So there are cases where you need to sort the elements in multiple cases. For example, you want to sort the elements lexicographically with the respect of their name, roll number, and maybe age. Okay. So you cannot go through the complex sorting techniques using just the for loop. In that case, you have to use the comparator interface, and it will be easy for you then. It's quite difficult to understand it like this. We'll just go through some questions later to understand this, how we can use comparator. And honestly, it's not easy part of this. So it will take time to grasp all the concepts, you know. But we also have one sort method in our collections, you know. So if you want to sort an array, for example, we create a list, maybe array list. Let me just create it. So we have, let me just create, yeah, man. So we have a list with a value integer, and we say li is equals to new array list, and you see we created it. Now what we want to do is we want to put some values in this list. So we'll just say that yeah, we are adding one. Maybe next element is 3. Next element is let's give it 6. So currently this is sorted, right? So now next element is 2. Not add 0 maybe. So you see the list is not, when we print the list, for example, if we um one second. Yeah, if we iterate over this list, I and we go through the li and we print out the elements of this list. So you get that it's not in sorted way. So 13620, it's not in sorted, right? Or maybe just do this. So you see that uh, from here to here we have the sorted, but then we got the it's not sorted, right? So to sort it, we have very simple method to sort it. You can just use collections,
Yeah.
collections dot sort, and we just need to give li, and now we can just print out our li again. Let's see. So you see now our list is sorted, right? Yeah, makes sense.
Yeah.
So let me just
Yes.
write it again. So
Can
you
you hear me,
see,
sir?
yeah, I can hear you. So in the previous case when we didn't sort it out, so in that case we had this 13620, and after sorting it out, so we just use collection dot sort, and it is sorted now. So you see 01236 something like that. Okay. Yeah. So we have a default sort method in our collections class. This one.
So yeah, yeah, that we learned this sort method
Yeah.
in
Yeah.
data
So
structure.
yeah, correct, correct. That one. So we are passing here a list, but we can pass a comparator as well. You see, it is only sorting in ascending one, right? You see that. So it is only sorting in ascending format. What if you want to sort it in descending? Okay. In that case, we need to give some comparator value. Okay. So let me just pass some comparator. I think we have some comparator here which is passed. Let me check. Yeah. So we
Yeah.
created a new sort by role comparator here. Okay. We just need to write this. You know, we just wrote this sort by role, and yeah. But we have some other ways as well. I don't know if I can use it here. New. We say that we want to use a comparator. Say that we need to import it first. Comparator. You know, and we create a class here as well instead of going through that difficult process. What is class anonymous class derived from comparator must implement abstract method compare. Okay, so we need to implement that. So we just click here implement methods, and yeah, we need to write the compare here. And what is the issue? Method does not override method from its superclass. Um, what? You can just remove the annotation. Now our first object, is in integer, right? So our object one is integer, correct? It's a list of integer, but we know that we are storing the integer only, so that's fine. And our object two is again integer, right? So that's our object two. And if we compare it, and what are we getting here? Anonymous class derived from comparator must implement method. We are implementing. What's the issue? At the rate override. Need to write this, but I think we need to add some implement something. I don't want to write this in a new class. Can we do this without that? So we are creating the object of comparator here using the new keyword. So it is asking us to not do that and just create a new class and do that. But how can we do that without creating something like that? Um, for now, let's just write our code. If you want to make it in ascending order, you see that we are just a dot roll number and doing that. So instead of doing that, we can just say we want this into our decreasing order. We'll just say O1. So it is fine. Why I'm not sure why it's getting something like this. Um, we don't want to remove the annotation. Something is wrong here. So class anonymous class derived from comparator must implement abstract method compare, and we are using that. Wait, we have a functional interface comparator. So either I think we are giving the, maybe let's me just give the comparable again. This is issues. Okay, never mind. We are not going to use comparator. We will be using comparable. So we'll just give some object in teaser. Let's compare this. So this is very confusing if you do it for after a long time. O2 minus 2 minus. Um, we are doing everything right, but just that it just asked me to write it in class. It is not letting me do that. Okay, so in
Can you
the,
hear me?
yeah, I can hear you. In that case, we'll just go through a class. So we'll just create this, just cut it out, and we create a class here. We'll say um, what we can say, class sort, sort in descending maybe. Implements, and it is implementing the comparator, and we are doing this, and we need to implement the methods. So I'll just implement the compare method. So here in this case, what we need to do, instead of object, we are having integer here, and we are having integer here as well, and we want to get the as descending one, right? Now what is the issue is method does not override method from its superclass. Why we are getting this again, man? We can just remove this maybe. Wow. So we are just forgetting this whole. Oh God. We could have done this here as well. Let me try it here. New comparator, and we are going to give it integer, and something like that. We will be implementing the method which is compare, and yeah. So here we'll be returning O2 minus O1. Again, we are getting issues. Remove redundant argument. Let me just remove this now. What it is saying, cannot resolve method println. What? Oh, okay, okay, okay. Hmm. We want to do this in sort, right? Why are we doing this?
We want to sort it in descending order.
Yeah, we are going to sort it in descending order, and we are done with our logic. Now we are going to print it.
Okay.
Sort li. We don't have to use the class now, another class. So let me run this. So in this case, you see we got our array in descending, right?
Yeah, the
So
output is
yeah,
less.
so using this collection dot sort, you can sort it out in ascending format, and you can also sort it out in descending format. But you just need to use the comparator, this one that you are using, new comparator and all, and just maybe can we do this even without this? Oh, we can't. It is anonymous new can be replaced with lambda. Okay, so here we can use lambda expressions as well. Now you see, what are we talking? So it's a very difficult code to understand, and it's from Java 8, I think. So you get to learn about the lambda expressions. So lambda expressions and streams as well. So we'll cover that in Java 8 when we learn Java 8. But
Okay.
this whole line you see. So we are trying to sort the array in reverse order using the comparator interface. Okay.
Uh-huh.
So what we
So
were,
Owen's replace.
so this will sort this element in ascending one, right? So this will sort it out in ascending, right?
Order.
Yeah, ascending order. Now, if you want to sort in descending order, what we can do? We can just say that collections dot sort. We say li and we give it a new comparator class, comparator, and it will write it on its own. Just have to give semicolon, and we just have to say O2 minus O1 because it will give you ascending. If you want it, sorry, descending. If you want it to be ascending, you just say O1 minus O2, or just leave it by default, and it will give you the ascending one. But we want it to be
Okay.
descending, so we just say O2 minus O1, and we get our descending one. And now you can simply run, and you get the reverse order. This one.
Yeah.
See, this is your descending order. But there is an easy way to do this. You know that
Okay.
you have to write this compare method, right? And you have to pass two values here because you're comparing it with each other, right? So you have to
Yeah.
pass two values. So can you short this code? Like, can you do some shortcuts? So you see, we don't have to necessarily write override because we have to write this. So can we just remove it? Can we remove it till this point? We just say that, okay, like this, something like that. And we don't even have to write the data type because we already know the data type in our list, that it is integer, right?
Okay.
And even we don't have to write the data type here as well. And you see, we have one liner statement here. So this is redundant, you see, and we can just directly use this. So this is also valid, but you see, we have only one line, so we can remove the curly brackets as well, and we can remove the return as well, and we can remove the semicolon as well, and we can just say something like that. So you see, it's very simple. You have to write li,
Mm-hmm.
you have to write o1 comma o2 in simple brackets, and you create a lambda expression here, and you say o2 minus o1. So it will take two inputs, which is o1 and o2, and it will return o2 minus o1 in the compare method. So
Compare. Yeah.
yeah, so this will also return the descending order. So you see, we are still getting the same output. So
Yeah.
that's the magic of lambda expression. So we are using lambda here. So it will take time to understand what it is all.
Mm-hmm. But I'm getting the concept
You're
of
getting the
lambda.
concept, right? So what is the
Yeah.
lambda expression, and how we can sort the elements, how we can shorten out our code and all.
Yeah.
Yeah, so that's all in the comparator. And um, I think the rest we can do in next session.
Yeah. So
For
two
now, this
o'clock
is
I have
more
to
than,
go for
yeah.
lunch.
Okay. Okay, then see you later. Bye.